Hello everyone, welcome. Can you hear me? So, thank you for joining us today on mruby 3.0 introduction webinar. We are very excited to be able to bring this event to you and be able to share the voices of those who have kindly agreed to give a presentation today. My name is Hiromasa Ishii, NPO General Manager. So I will be the moderator today. Nice to meet you all. Please call me Hiro. So I will be giving you a quick tour of what you can expect today from us. First, we bring you a keynote from Matz, Yukihiro Matsumoto, a creator of Ruby and mruby. He's going to show us not just what is coming with the release of mruby3, but tell us about the future of mruby. Then we have three technical sessions. All of them are mruby evangelists. After all the streams, we will open our live Q&A session with Matz. We solicited some questions online, but please ask your question in the comment on YouTube. So, shall we begin? Keynote Matz. Okay.
Hi, this is Matz, the creator of the language, and also the main implementer of mruby, the alternative implementation of Ruby. So today today I'm going to talk about the mruby 3.0, which is planned to be released soon, very soon. I need to be clear that the mruby 3.0 not equals to Ruby 3.0. Ruby 3.0. Recently we are very we talk a lot about the Ruby 3. So the Ruby 3 is the version 3.0 of Ruby language, Ruby the language, and also the version 3.0 of the Ruby implementation, which is the canonical implementation of the language. We are going to release Ruby Ruby 3.0 on December 25th this year, 2020, as a Christmas gift. In contrast, mruby 3.0 is a version 3.0 of the mruby. The mruby is the alternative implementation of the Ruby language. We have the many implementation of Ruby languages. For example, the JRuby, which is on top of the Java Virtual Machine, JVM environment, or the Truffle Ruby, which is based on the Graal technology from Oracle Graal. Then mruby is the another alternative implementation of Ruby language. The mruby is the Ruby implementation for the embedding in scope. The mruby is plus Ruby. M stands for the embedded, or minimal, or modular, or Matsumoto's, because the early stage of the Ruby development, the multiple Matsumoto, including me, is working on. So that anyway, the mruby project was started in 2010. So which is a 10-year-old project. It's kind of the old project in the open source software world. And at that time, the Ruby was 1.9, so the language was forked from Ruby 1.9. Then the the ISO standard. The Ruby was standardized by the ISO. The in embedding field, especially the embedded device field, the ISO or the some kind of the canonical standards is very important. So that we decided to support ISO, the Ruby international standard, which is ISO 30170 2012. But the Ruby itself, the Ruby the language evolves after the 2012, so that we add some enhancement, which were added to the language since 2012. But most of these enhancements are options, so that you can drop off everything to get the minimal implementation as a core. But you can add these enhancements to make Ruby language, mruby language, close to Ruby 3.0. But some features implemented in Ruby 3 is not implemented intentionally for some reasons. One reason is a memory problem. Because of the mruby is designed for embedding, so that the memory is the biggest constraint. So the some features requires more memory, so that we had to give up those implementation. Another issue is the implementation difficulty. So that some features are very difficult to implement in the efficient way, so that we just gave up. Those features included in, for example, the refinements, raptor, async fiber, pattern matching, introducing the 2.7, and the threads. We have optional library that provide a feature, threading feature, but the behavior is different because of the mruby supports the platforms which does not have any threading support by the platform. For example, the mruby runs on the embedding OS operating system, monitors, or even without any operating system. So that those environment we cannot provide threading feature. The C extensions, the mruby does not support the C extension for cruby. So that C extension wise, those implementations are not compatible. That means that we have many Ruby gems, but we cannot use those gems from mruby. And require, so that, as I said before, some platforms does not have file systems, so that you cannot load from file systems on those platforms. So that the core does not provide the required feature or any file dependent features. All of them are optional. So the language wise, it's highly compatible to Ruby 3, except for some features I stated before. So that means that it's okay to run your Ruby code. But we don't have Ruby gems, we don't have C extensions, we don't have gems, so that the supporting libraries, that we have the different ecosystems, so that you cannot expect your existing Ruby application to run on mruby, which is the biggest difference you have to note. But instead, we have the packaging system named mruby gem, the gems for mruby. it's statically linked because of it's have to run on the platforms without file systems. And so you can use mruby to make your Ruby code run everywhere. That you can embed Ruby in your application. You can run your Ruby code on the small devices. So that the broadening the possibility or programmability is one of the goal of mruby. So that everywhere means Ruby, you can run Ruby on many devices, servers, in the applications, and even games. For that purpose, the mruby is highly portable. mruby runs on the Intel machines, ARM machines, MIPS machines, Spark machines, and then many CPUs. The mruby also supports many platforms in operating systems: Linux, Android, Mac OS, iOS, Windows, or even without operating system. So that, for example, we have several applications that embed mruby on the, say, iOS. So that, for example, we recently see the applications named the Rubyist app, which embeds mruby in it, so that you can control your iOS from using Ruby. The minimal Ruby means mruby can be minimal. The smallest memory footprint is 96 kilobytes. But you have to strip down many things. So, for example, you have to strip down the extensions. You have to strip down the regular expressions, the newer feature implemented in Ruby 3, Ruby 2 point something, 2.x, and or you may need to drop down the browser and code generators. So the only virtual machine takes 96 kilobytes. That means the mruby is designed to be modular using mruby-gem. We have the program, the tools named mgem, which manages the mruby-gems. So that you can install mgem using gem install. Then you can update the gem information from using the mgem update. Then you can take the list of the gems from the internet. If you type mgem list, you will have the many list of gems. You have the mruby processes or those many things. This is one example. Many gems. It's the set is far smaller than the mruby gems, which has the 20,000 or maybe, I don't know, 200,000. Many gems. But the mgem list has currently the 308 gems. It has the database gems, the operating system control gems, and many gems. Using mruby, you can run Ruby everywhere, from microcontrollers to servers. So that you can provide the programmability to users. Programmability is the key of the usability. For example, the Emacs was the editor, but the author, the Stallman, added the Emacs Lisp as a configure programming language. By using those that programming language, so that you can enhance the editor to platform. the Emacs can run mail readers, web servers, games, and many tools supporting editing, supporting whatever you want. So the Emacs became a platform by the programmability. So you can add similar programmability to your application. So the more programmability is the key. So for example, the web servers, you can add the mruby embedded in Nginx and Apaches, and some people use mruby as a web sandbox. The Shopify provides the application of the mruby engine, which embeds mruby so that the untrusted user code can be run in safely in a sandbox. Some games embeds mruby. For example, Nier Automata embeds mruby. I've heard that. And Sid Meier's Starship is currently in development using mruby. The other things, for example, the microsatellites from the QPS lab in Japan embeds mruby, and the circling around the Earth. They plan to launch the 36 microsatellites all over the globe, so that you every 10 minutes, every point on Earth can be monitored. This is quite interesting challenge. Those microsatellites is controlled by mruby program. Some internet routers from IIJ Inc. Are controlled by the mruby, which provides the rules and the user interface using mruby. The CloudWalk Incorporated implemented the payment devices using mruby. And there are open source provisioning tools, Mitamae, using mruby. Mitamae is a kind of the chef-like provisioning tools, but it's single binary, so that you can copy the one binary to the client, so that you can use the provisioning it as a provisioning tool. Some people use mruby as a prototypes for the home appliances, vending machines, the automobile dashboard. So that these days, those systems are implemented mostly in software. So the logic in the software is getting more and more complex. So that they want to use the more productive programming language. So that they chose Ruby to implement their logics. But in production, so the required memory is bigger, and required CPU power is bigger. So that they try to compile those logics, which is prototyped and experimented in Ruby, into C or assembly. But those trial and errors phase, the using Ruby language is make them very productive. Some hobby devices, some people try to use those hobby devices, the M5 stack, M5 stick, or BBC microbit. The second generation microbit has the more memory than the first generation, so that you can safely run the mruby on top of it. So that this is mruby. Then, what's new in Ruby 3.0? What's how we've improved mruby 3.0? The one thing is numbers. In mruby, integer division result in float because 3 divided by 2 equals 1.5, which was natural. But remember, so that mruby was started in 2010, 10 years ago. And at that time, I was going to change the Ruby language like that, so that integer division makes float. Well, but the compatibility issue was bigger than I expected back then. So the core teams discussed a lot and abandoned those kind of the huge incompatibility in the language. So this is the good chance to follow the CRuby path, so that we change the rules, so that make integer division makes float. And then for the same reason, so the mruby result the float from the integer overflow, but we also abandoned this change, so that the float and the integer mixture was reduced in the mruby. Those are historical reasons. And we also added the rational and complex numbers to the language. They are optional though. And we have improved the build process. For example, you can do the reg test, but at the same time, you can specify the configuration by the predefined configuration. For example, this one, mruby config, the clang async, is compiled using the LLVM compiler with the address sanitizer options on. The implementation wise, the biggest change is the reduced memory. We chose the pre-allocated symbols so that you don't have to allocate many symbol tables on ROM, not RAM, so that you can reduce the RAM consumption. As a result, you can put the irep structure, which irep is the internal representation of the blocks and the methods, so that you can put those things on RAM, so that you can reduce the RAM, the precious RAM use consumption. We also improved the data structures for the hashes and the method tables and the instant variables. We also added the new methods in 2.7 and 3.0, and we fixed many bugs. And remember, so that Shopify provides the sandbox, implemented the sandbox using mruby. That if it has some kind of a security bugs, it's a security bug for the sandbox. It's a hole in the sandbox. So the Shopify declared a bounty for the security bugs, so that people, especially the bounty hunters, the bug bounty hunters, found many bugs, but that we fixed them all, all reported bugs. We also registered Google's OSS Fuzz program, so that they try to put the random input into the interpreter, so that the interpreter won't clash. So that we fixed them all. So that this is mruby 3, which is soon to be released. So that for the further future, the mruby 3.1, 3.2, so that we have planned for the better support for the microbit and the M5 stack. So that we need to focus more on the hobby programmer using devices, so that our forerunner and the rival is the MicroPython, and then MicroPython is very strong on those devices, so that we improved support for the smaller hobby devices. And we are also working on the multi-precision integers. So that in cruby we have big nums. The integer is a arbitrary precision integers. But at the moment, the mruby has a fixed size integers, 64 base or 32 base according to the configuration. But it's quite limited and the big difference. So that we are going to make integers multi-precision by option. For many applications, 32-bit integer is big enough, so that you don't have to spend more memory. So it's totally optional. We also are going to address the pattern matching. The pattern matching is very useful and convenient for the many cases, so that we are going to implement it in the future. So this is how it goes. By using mruby, you can provide the programmability for your applications. Your application will become platform, not just an application. This is a very great opportunity or possibility of the future of your application. So that, the lifetime of the mere application is shorter, for example, 5 years, 10 years. But providing a programmability extend the lifetime of your applications. But now you don't have to implement the scripting language for your application. Just use Ruby. Just use full Ruby using mruby. This is great opportunity for your applications. The mruby 3.0 reduce the required memory and provide more features from Ruby language. And there are more and more gems to provide the core features. And this is great possibility. We invite you to use mruby, involved in the development of mruby to enhance the future, enhance the possibility, and make the great software applications, and make the world better place and a great place to live for programmers and public general. uh, this is the end of my this is the end of my presentation. So that thank you, and we are going to have some kind of the QA session afterwards. So that feel free to ask me any questions related to mruby or not related to mruby or whatever. Thank you. Bye bye.
Hi, thank you very much, Matz. It's a very interesting story. I remember Shopify's The Bug Bounty. Yes. So you can download the mruby from GitHub site. Please search the mruby at the GitHub site. Then next we bring you a 3 technical sessions. So we'll prepare the streaming. Please wait a couple minutes. Don't go away. I'll be back. Hi, here's an announcement from the organizer of Fukuoka Ruby and Software Industry Promotion Committee about the 13th Fukuoka Ruby Award competition. If you have developed an interesting Ruby or mruby program or business model, please be encouraged to apply. Please check the QR code. Grand prize is 1 million yen. Thank you. Thank you for your patience. So we're gonna start the 3 technical session. First, Yamane-san will talk how to enjoy mruby. She's very familiar with mruby and made great achievement regarding to reducing memory consumption in mruby 3. Then Mr. Mimaki of SSK Kyushu talks about the IoT platform Plato. By only drag and drop, Plato generates mruby IoT applications. He will explain how mruby controls the hardware easily. After Mimaki-san, Mr. Tanaka, Associate Professor of Kyushu Institute of Technology, talks about mruby/C. It's a smaller mruby. So we will begin. Engage.
Hello everyone, I'm Yuri. I have developed mruby application and development tools for mruby. I'll talk about mruby on microcomputer. What can we do with mruby? First of all, this is what we made. This is M5 stack. It's a famous board in China and Japan. There is an ESP32 microcontroller on it. This is RubyConf 2018 demo. This is M5 stick C. This is cheaper than M5 stack. If you shake this, the dice will change. I get the sensor value with M5 stick C and publish to AWS IoT. The published data can be viewed on the AWS IoT screen. Do you know Washet? The Japanese toilet automatically open and close the lid when human approaches. I will show you a demo, but before that, I'll explain the action bridge. At the beginning, the lid is closed. As you approach to it, sensor detects you and the lid opens. Like this. Once you sit down, you can operate the washlet, because if the washlet moves before sitting, the floor becomes submerged. When you press the button, it starts spraying. If you push the button during spraying, the spray will stop. When you stand up and go out, the sensor detects that you are gone. The lid closes. Let's watch a movie of Washlet. As you approach it, the sensor detects you and the lid opens. If you sit down, then you can press the button. When you press the button, it starts spraying. If you push the button during spraying, the spray will stop. When you stand up, the sensor detects that you are gone and the lid closes. This is made by using a microcontroller board, sensors, and motors.
D.
Do you know the machine? Yes, it's a Segway. Segway is one kind of self-balancing machine. I explain briefly invert pendulum. Invert pendulum is unstable. It falls down right or left if you give no power to the wheels. When it falls to the right, we must give our power to the wheel to move right. Then it stands vertically and keep balance for a few moments. When it falls to the left, we must give power to the wheels to move left. By repeating more and more, it keeps balance. If you repeat this well, it looks like it's still. mruby also works with Raspberry Pi. This is a self-balancing robot made using Raspberry Pi. Child sensor is on the front side. Battery for motors is backside. To stabilize power, we need another battery for Raspberry Pi. Raspberry Pi uses SD card and bootable devices, so we copy mruby binary into SD card. The next one is an evolution of the self-balancing robot, which moves by sensing the black line.
これ本当に手動のでオンオフで切り替えてるだけなので、ちょっと走り方は無作業な感じではあるんですけど。
But better for mruby3. The good news for microcomputer programming that it requires less memory. Looking at this table, you can see that more RAM means a higher price. mruby is not yet available on Arduino, but it can run on a cheaper microcomputer than Arduino. Why does a microcontroller have less RAM? First of all, the reason is the cost. Microcontrollers tend to be used for devices with only a simple function, so they need only the minimum amount of RAM. Another reason is the problem of power consumption. RAM requires power to hold data. This means that as RAM increases, the power consumption also will increase. mruby requires more RAM than other languages. For example, in the case of a microcontroller that is supported to write programs in C, mruby is too big to fit on. So with mruby3, but only did mruby use less RAM, but we are able to make it even smaller by using ROM as well. Like this. Some microcontrollers have large RAM. However, these have large RAM for a purpose. For example, if you want to do image processing or want to do communication. So if mruby uses it because of its large RAM, it will not be able to do these things. After all, we will be happy if mruby was smaller and could process images and communicate from mruby. In addition, you can now do things you couldn't do before. It's smaller, so you can run multiple mruby. Then you can do more things, such as use RTOS for parallel processing. For example, a 96 kilobyte microcontroller can run to mruby. That's all. Thank you for coming and let's enjoy mruby.
I'd like to introduce the IoT platform mruby that uses mruby. My name is Hiroshi Maki, and I belong to SCSK Kyushu Corporation and the specified non-profit organization mruby Forum. First of all, I'd like to talk about the IoT. This figure shows the service structure of IoT. In order to realize IoT services, it is necessary to integrate the cloud, network, and devices. Creating all of this is extremely difficult and needs both technically and laboriously. Many services are provided on the cloud side, and it is possible to utilize them via REST API and MQTT. It's becoming standard. However, in the area from devices to networks, there are few effective platforms that can be called standard. Therefore, we have developed the IoT platform mruby. mruby was jointly developed by Braveridge, Kyushu Institute of Technology, International Laboratory Corporation, and my company SCSK Kyushu, with the support of the Ministry of Economy, Trade and Industry Support Project. mruby features support Bluetooth 5.0, that is long-range version, and LoRaWAN network. By drag and drop, mruby generates IoT applications with a very easy GUI. Support security function. Next, I will explain the constitution of mruby's IoT network. Edge devices with sensors connect to the bridge device via Bluetooth. Bluetooth can communicate in long-range mode and can communicate up to about 1 kilometer. The Bluetooth LoRa bridge relays the sensing data received via Bluetooth via LoRa. Then it reaches the internet from the LoRa gateway. Since the transmission distance of LoRa is about several kilometers, it is possible to build a wide area IoT network by using mruby's edge devices and bridges. Even if you cannot use LoRa communication service, you can build a network using private LoRa by purchasing a commercially available LoRa gateway. This is the hardware specification of mruby device. The edge device and bridge are almost the same in terms of hardware. The SoC is Nordic's NRF52840 and controller is ARM Cortex-M4. It has 1 MB ROM and 256 KB RAM. With 256 KB of RAM, mruby 3.0 will work, but mruby 2.1 At the time of this development was difficult to run the application. Therefore, in Plato development, we adopted mruby/c, which can operate with low memory. mruby/c is a smaller mruby, and Mr. Tanaka will explain this after this session. The device interface supports GPIO, UART, I2C, and SPI, and various sensors and GPS are connected to it. And this is Plato's software structure. We installed a mruby/c virtual machine in the firmware and ran the Plato framework on it. The version of mruby/c is 2.1. The Plato framework includes an application framework and a device class library. The above is the software provided by Plato. IoT applications can be freely created by the user and written to the device using the Plato GUI. The following is a brief description of the basic structure of the Plato application. Plato has defined three elements, which are sensor, timing, and action. Those make up an IoT application. Each of these three elements defines what, when, and what to do. We have made it possible to building an application by grouping these three elements into a unit called job, and operating multiple jobs in parallel or in conjunction with each other. Let's take a look at the demonstration from creating to executing an IoT application using Plato. Now, create an application using Plato. First, select Create Application. The basic information setting screen of an application is displayed. This time, I'll create an application that periodically acquires temperatures and humidity. So the application name is TempHumi. Group settings are network settings. Although detailed explanation are omitted. This time, select the pre-registered group 1 and click Next. Next is job registration. Register job by selecting in the order of sensor, timing, and action introduced earlier. Add temperature and humidity from sensor. From timing, specify interval and set the time to 5 seconds so that the operation is easy to understand. From action, specify Bluetooth transmission and register job. The jobs added to the job list screen are displayed. It is possible to add multiple jobs, but this time I will create an application only with this job. Check the contents of the application confirmation screen and click Create to generate the application and display the source code in Visual Studio Code. Create a job sensing temperature and humidity every 5 seconds, sent via Bluetooth. you can see that the code was generated. The generated Ruby application is compiled into binary. Now, let's write the generated application to the Plato device and see how it works. This is Plato's edge device. Click Deploy Application to launch the transfer tool. First, select the device in Scan Plato device. Then, under Select Application Binary, select the temp-humi application binary. Temp-humi. Click Deploy to start transfer to application. During the transfer, the LED of the device flashes blue, and when transfer is completely succeed, it flashes yellow. Now that the application has been written, let's check the operation using the simple viewer. Select the device as before and start data notification. You can see that temperature and humidity are displayed every 5 seconds. You can see that value changes when I touch the sensor part. In this way, Plato allows you to create IoT applications and write to device with simple operation. Next, I'd like to introduce how to realize device access with mruby/c. First, the application calls the sensor class. The sensor of the edge device is connected by I2C and acquires data via I2C class. The I2C class is implemented in Ruby and C, and it is possible to control the I2C device by calling the I2C communication process implemented in firmware from the process implemented by C language. Sensor classes that use I2C will be able to be controlled only by classes implemented in Ruby. Similarly, for UART and SPI, by preparing a class for device interface, the device class can be implemented only with Ruby. Now, I'll briefly introduce the device class implementation of the temperature and humidity sensor. This is the device class of the temperature and humidity sensor, SHTC1. The read temperature method, I2C read command calculates the temperature based on the temperature data read from the SHTC1 sensor via I2C. Next, let's take a look at the I2C class. This is part of the Ruby implementation of the I2C class. The read command method calls two C implementation methods, _write and _read, to write the command and read the result. And this is the C implementation of the I2C class. This is the process at initialization, which defines the I2C class and I2C _write _read. When the _write and _read methods are called, the C functions, C I2C row write and C I2C row read, are called, And this C I2C row read is the C function called by I2C underscore read. In this process, device control from Ruby code is realized by calling the I2C read process of firmware. Once the I2C class is created in this way, devices controlled to I2C can be operated only with Ruby. If provided device interface classes for SPI and UART, you can easily implement the device classes themselves. I think it is one of the big advantages of using mruby/c and mruby in embedded development. And the end of description, it is a summary. With Plato, you can create IoT apps with a simple GUI operation. You can control the device with mruby. The strength of mruby is that it can be used by incorporating it into a C programs. You can extend your application simply by running a virtual machine on the firmware. Developers are also happy to be able to create a hybrid configuration in which controls are written in C and applications are written in Ruby. And the future of Plato. Small IoT using only Bluetooth. LTE-M and mruby3 support. This is the introduction of the IoT platform Plato that uses mruby. Thank you.
Thank you for joining today. I'm Tanaka. I talk about mruby/c3, which is mruby for smaller devices. I talk about this point. My name is Tanaka. I'm an associate professor in Kyushu Institute of Technology. Of course, I am a mruby and mruby/c developer. Usually, I have lectures about data structures and algorithms and robot sensor processing and so on. So I am mainly lecturing about information science, computer science. And also I have a research related to the embedded software. This is, of course, this is about mruby. And also low power wireless communication and its protocols, which is called LPWA. I usually do such works. Before talking about mruby/c, I'll talk about mruby, the mechanism and execution style. So mruby is one kind of Ruby language, and mruby is usually compiled to the mruby bytecode that is called mruby file. And this is device-independent code. This code, bytecode, is loaded to the mruby virtual machine and execute the bytecode step by step. This is mruby. Next is about mruby/c. This is pronounced mruby/c. So the mechanism is almost same as mruby. That is compiled, generated bytecode that is executed on the virtual machine is the same. mruby/c is another implementation of mruby virtual machine. So the bytecode is exactly same as mruby. Of course, because mruby compiler is the same compiler I'm using. And bytecode execution, that is the virtual machine, is different. And this is a point of the mruby/c. So another implementation of mruby virtual machine. Then, what is the difference between mruby and mruby/c? The concept of mruby/c is following 3 points. The first is mruby/c is supporting various CPU, various architectures. A smaller CPU and larger CPU is anything okay. And also the porting is very simple and very easy. just rewriting several lines, very few lines. That's all about the porting. Next point is mruby/c requires small memory. Minimum is 8 kilobyte, but maybe 8 kilobyte is nonsense. 16 kilobyte is very popular as the minimum. And larger is anything okay. So mruby/c consumes a very small memory. And also mruby/c is has a concurrent execution mechanism. And this is called multi-programming. Several programs are implemented and execute them concurrently. That is a concurrent execution. Okay, next is mruby/c3. This is the latest version of mruby/c. mruby/c3 is supporting several features. First is static string and static symbol. This is contribute to the memory consumption. And next is newer opcode in mruby3. Previously, I talked about the difference and same point between mruby and mruby/c. So the bytecode is exact same as mruby and mruby/c. So mruby/c should support the new opcode in mruby3. So we are supporting this point. And upgrade point is newer virtual machine structure. This is the internal structure of mruby virtual machine upgraded, and newer memory allocation algorithm. Algorithms are also almost same, but newer implementation of memory allocation functions. This is contribute to the memory consumption and allocation speed. Currently, mruby/c3 branch is released in the GitHub. I talk about the porting to any devices. So almost all of code is device independent, just C language, very portable. And last few percent of this code is device dependent. So about 0.3% is dependent. So we must rewrite or we must implement this device-dependent code importing. So more details about the porting, we must rewrite 6 functions. These functions are listed here. HAL related functions. HAL init is HAL initialization. HAL is hardware abstraction layer. So hardware dependent code is concentrated here. So HAL enable IRQ and HAL disable IRQ is enable and disable of the interruption. And HAL idle CPU is so that is waiting 1 millisecond. This is a waiting function. And HAL write and HAL flash is this is a standard out of to the console. So just rewrite the 6 functions. That's all about the porting. And also we provide several HAL implementations for the ESP32, that is one microcontroller board, and PIC24 and POSIX and PSOC5LP. Several HAL is already provided. Maybe you can refer these HAL functions, then you can rewrite the HAL functions for your own devices. They are target devices for mruby/c. They are very popular in our development. And we also provide IDE. So this is a development environment. mruby/c is supporting concurrent execution. So please look at this red circle. Several mruby code is listed here. So this listed code is executed concurrently in target devices. Okay, let's move to about the memory management. This slide and the next slide is very related to the technology and very detailed of mruby/c. About memory management of mruby/c is using TLSF algorithm. This algorithm is very fast, and the computation order is order 1, so very fast. That means very fast. And also the mruby/c is focusing to the many target devices. So some target devices is dynamic memory allocation mechanism is already implemented, like Windows or Linux or something. But some kind of real-time operating system is statistical memory allocation is supported. That's all. So mruby/c is supporting such statistical memory allocation. And fixed memory, this means RAM is fixed and address is fixed. So constant address is necessary for the initialization and so on. So mruby/c is supporting several type of memory allocation. So mruby/c requires only 2 points in execution about a memory. So starting address and memory length, that's all. That's why. So mruby/c is adapted to the many kind of memory allocations. So mruby/c is mruby/c has own memory allocation mechanism in virtual machine. This is the result about the sample program. This program is very simple. So first, the empty array is assigned, and adding 100 numbers to that array, and print the array. So memory consumption is 7,400 bytes. Use memory you can see. And also a good point is memory fragmentation. That only 3 fragmentation is occurred in this sample program. So very few. This is a good point of the memory allocation and memory management features in mruby/c. This is another result of the sample programs. There are 2 programs. Left side is 100 entry of the array. Right side is a 200 entry of the array. The difference is number of the array, size of the array. Okay, and memory consumption is also of course different because the number of the entries element is different. But the difference is exact same as element of the array. Difference element of the array. So one element of the array is 16 byte, and the total difference between 100 and 200 is 1.6 kilobyte. That is exact same as 100 elements of the array. So this mruby/c memory allocation feature, memory allocation algorithm is a very good point in the memory consumption. This is very good at memory usage. Thank you for listening today. There are references of the mruby/c. Of course, mruby/c is open source software, so we released and we opened in GitHub this site. And also detailed or some references or documents about the mruby/c is released from this site, following site. So please refer these references, and if possible, please use the mruby/c for your work or your researches and so on. Thank you for listening again.
Thank you. So then we start the Q&A session with Matz and Mr. Tanaka, Associate Professor of Kyushu Technology. So how are you? How are you, Matz? I hear you. So Mr. Tanaka can talk something. Hi. Thank you. Thank you for coming. So we have the question, several questions. So first one is Mr. Ken. There is a work going on with Rust and WebAssembly. Is it possible to do the same thing with mruby? It would be wonderful to write the back end in rather than the front end with mruby and WebAssembly. That's a good idea, I think. Can mruby support this one?
Actually, I don't know, because there are some attempts to run mruby in the WebAssembly. So, for example, some guy tried to compile mruby, the C code in using the M script, which compiles C code into the JavaScript.
Mm.
And then they run in the browser. But as soon as the mruby virtual machine compiled the JavaScript is loaded, the browser consumes the 4 or 5 meg of memory. So that it is quite huge and slow. The another attempt is the Ruby implementation named the Artichoke, which is based on mruby, and it is highly modified version of mruby, and it uses the Rust, and the Rust, one of the Rust target is the WebAssembly. So that using Artichoke, I think you can compile Ruby code into the WebAssembly, but I'm not sure how far they go.
Yes.
Right now.
Yeah. Thank you. So how about Mr. Tanaka?
I understand that the benefit of the mruby is the benefit of the WebAssembly. That's a very good idea, and I hope so that's execution. But maybe that is very difficult because every bytecode should be compiled into the bytecode. So such compiler is also implemented on somewhere on the assembly or something, and execute on the virtual machine. So virtual machine itself implemented on the WebAssembly is very possible, I think. But that's a good idea and very interesting.
Hi. So the Matz's voice and the Tanaka-san's voice is missing now. So
What?
really?
I can hear the Matt's voice.
I can hear too.
So what's going on? Oh really? Why does this happen? Desktop on sheet. Sorry everybody. The small technical problem happens. 聞こえた? So it may be okay. So would you please tell something, Matz?
Yes, yes. Can you hear me?
I think it's okay. How about Mr. Tanaka?
Yeah.
Say something.
Can you hear me?
Okay, so cut it. So we'll begin again. 上出して。読む。So I read the one more time. So first question we would like to talk. Sorry that Matz's voice and Tanaka's voice is missing. So start again. Thank
Okay.
you. Thank you.
Okay.
Again from the
So
beginning?
very sorry about that. So there is a work going on with Rust and WebAssembly. So how do you think about this one, Matsu?
How fast or slow? Which one?
Yeah, first one. The Matsu's
The
voice is
WebAssembly,
missing.
yeah.
So nobody listened to the Matsu and the Tanaka's voice. So give me answer
there is work
again.
going on the Rust one.
Okay, answer
Okay.
again, please.
Rust. The mruby virtual machine is written and implemented in C, so that basically it is no relation with the Rust. So that there are some extension that you can allow that you can write the mruby extension or gems in Rust, but I'm not sure the status of the extension right now. In addition, so that there are some attempt to the compile mruby into the JavaScript or WebAssembly. For example, in the past, a guy tried to compile the mruby using the mscriptm, which compiles the C into the JavaScript. And then, so that you can run the mruby virtual machine in the browser, but as soon as it started up, it consumed a lot of memory, so that it runs very, very slow. So that I'm not sure it is realistic usage or not. And the another attempt is the Ruby implementation named Artichoke, which is based on the highly modified version of mruby, and then I've heard it runs okay, and one of its target is the WebAssembly. So that I think using Artichoke, so that you can compile the Ruby code into the WebAssembly.
Thank you. So, Mr. Tanaka, how about you?
Yeah, the idea of the mruby on execute on the WebAssembly, that is a good idea, I think. So the point is, so mruby code is compiled to the mruby bytecode and execute on the virtual machine. So virtual machine itself on the written in the WebAssembly is a very good idea, and maybe that is possible. However, the compiler is the problem. So compiler is a very complex and complicated code. So that is on the WebAssembly environment is so I wonder the performance is okay or not. So that is I'm concerned about the WebAssembly side, I think.
So you mean
But
that?
idea is very good. Idea is very good.
So you mean that it's not enough this time? So somebody need to develop something about the virtual machine world or something. But this is a very good idea.
Yeah, I think so.
So thank you. Just from question from Ken. Thank you, Ken. So next one. How fast or slow is the speed compared to mruby3 and cruby?
The mruby is the primary goal is not the performance, but the performance-wise, it is slower than cruby, and it is faster than the Ruby 1.8, so that it's in the middle. So the memory consumptions is our first goal, and so the performance is not that much. So that we are trying to improve that, but the cruby tends to consume memory for the sake of the performance. So I don't think it would be as fast as cruby in the future.
Okay.
A little bit slower. You have to expect it a little bit slower than cruby.
Thank you. So how about the mruby/c comparing the cruby?
mruby should be compared to the mruby, I think. So compared to the mruby, mruby/c is slower, exact slower than mruby because the function searching is that bottleneck of the mruby/c. And so mruby is the function searching is very fast by using some hash table or some algorithms. However, the mruby/c is using the linked list. So if the number of the function is increased, the searching time is also increased. So that is a limitation of the mruby/c. So very slow. But memory consumption is very small. That is a good point, I think.
Thank you. So next one. How much memory does mruby3 use? 98 kilobyte.
The mruby virtual machine fit in the 96 kilobytes. Probably consumes, I don't know, maybe the 60 kilo or something. But the program itself used the memory, so that I can safely say that 96 kilobyte of memory can run the mruby virtual machine with some modest Ruby code.
It's quite improvement comparing
it's quite
the first
improvement.
one.
Yeah, we a few years ago it requires several hundred kilobytes.
So mruby/c is smaller than mruby. How many memories?
mruby/c is minimum is 8 kilobyte.
8
So
kilobyte.
8 kilobyte. Yeah, 8.
Wonderful.
But usually 16 is the usual case.
Yes, wonderful. So next one. When can I expect to have the stable version of mruby 3.0?
I also ask.
It's supposed to be it's supposed to be released but
this year.
Right, within this year.
Yeah,
actually, recently we got some bug reports to be fixed, so that I'm pretty working hard to fix them all. So that wait for a moment. We have to ensure the QA process, so that it would take two weeks. So I hope we can release it within this year.
Yeah, stable is very important for this kind of the program language. So
Yeah.
yes, we are waiting.
I'm sorry.
I'm
Thank
waiting.
you. The next
Yeah.
one. I understand that the mruby/c has low memory consumption, but I think it has some limitation or restrictions. Tell me about this. So,
Yeah.
Mr. Tanaka.
Yeah. The limitation is the performance. First is performance in execution. So that's the limitation or that's the weak point in mruby/c. And also the more complex exception handling is weak as the mruby/c. So exception, complex exception handling. So simple exception handling, there's no problem, but more complex or deep expression exception handling is a weak point or in mruby/c. Maybe many points is a weak point in mruby, but the main point is the two. So execution performance and exception handling.
So how about mruby? Another questions about the same questions.
A limitation.
Yeah, limitation.
Yeah. How about Matz?
Yeah, Matz, how about the mruby? No limitations.
We cannot catch up all the Ruby C features. For example, the refinements of pattern matching, and that is kind of a restriction. And then we have very teeny incompatibility, like we lack some methods in say the garbage collector or something. And we lack the performance was like a JIT compiler. In addition, what else? So we lack the big nums, so the arbitrary precision integers. So that is great. The big restriction from CRuby. And the performance. So that the mruby is the slower than CRuby. So those are the limitation of mruby.
Thank you. So next one, more. Next one. Oh, is there any book for mruby? Yeah.
Actually, we are going to publish the mruby internal book in Japanese pretty soon. So then we are under the process of translating the book into English. So that maybe in a few months, so that we can publish by the English version, maybe in the the ebooks.
Oh yes, so it's a PDF or something from the internet. You can download this book and like Amazon look inside. The several chapter is free. I heard that. So we are going to publish the PDF version of the mruby English version book soon, I think. So please wait a while. Then next one. Does mruby 3.0 support specifying the type of the variable as in Ruby 3.0? It's not now.
Basically, no, because the mruby itself does not support any static typing. But even in the Ruby 3.0 does not have the type annotation or the type declaration in the language. But that means you write the Ruby code so that you run on the type prof tools. So that even for the Ruby code for the mruby, you can apply the type prof, so the separate type checking tool on your Ruby code. So that is one benefit. So that you don't have to write change anything to the check type for your Ruby code.
Yeah, thank you. So this is the last one. So is there anything need to say? So how about Matz? Tanaka-san, how about please say something at the end of this session.
Yeah, as a nature of the open source software, the feedback from the community is very crucial, very important for us. So that, and it is, the community of the mruby is far smaller than the Ruby, the C Ruby and the Ruby itself. So that means your feedback is even more important. So that if you see anything weird, anything broken in mruby, so that feel free to contact me through the any channel, the Twitter, or maybe in the GitHub issues or whatever. So that we are waiting for your feedback. Yeah, we are looking forward to work with you. Thank you.
Thank you, sir. Thank you. So thank you for everyone watching us there. One more thing, we will send a post-webinar survey. So hope you reply the survey. So thank you very much, everybody. Say bye. Goodbye.
Thank you very much. Thank you for coming.
Thank you very much.